I'm Lisa. I just graduated from UC Berkeley. I'm going to be presenting information about a paper that I published with Sarah Chasins and David Antoff at Berkeley, and next year I will be a postdoc at Stanford. So hopefully keep working on this stuff, and always happy to chat. So I'm going to be presenting the findings from a recent paper that actually examined the usability of a package that I and my advisor built. So this is sort of giving power to the user by physically watching what the user does and then trying to infer what would be helpful to them and where their pain points were, which is like a really fascinating experiment to do. I highly recommend it. Super time consuming, but really interesting. Okay, so I'm going to be talking about mimi.jl. This is an embedded domain-specific language or package. I'm going to be saying eDSL because that's the term we were using in the publication, but you can think of it as a package too. Same thing in this case. For integrated assessment models. These are like cornerstone models in the climate economics field, and very broadly, they calculate what the economic impacts of climate change will be, and then produce values that are meant to be really useful to policymakers and regulatory agencies. And they're used very widely, and they couple a lot of systems together. So they couple climate models, like the ones we've been talking about, generally emulators that are emulating the more complicated behavior of models that take months to run, with socioeconomic projections, and then also with models of the economy. And they are mostly used by non-programmers, right? So these are not people who are programmers initially. Quick features, similar to a couple of the talks, we're focused on this being very extensible and modular in this sort of like Lego-like approach. And we really try hard to match our syntax and structure to the mental mapping of our domain experts, who are often not coders again, at least not coders first, so it's helpful to sort of like match to the domain language. Some of our models are actually built as packages, so we have to deal with package management and package development often, a design decision that's had some unintended consequences, but here we are. In a very Julia way, we use custom types and multiple dispatch quite a bit, and perhaps more controversially and problematically, we do depend pretty heavily on macros, which was not a decision I made. I hope my advisor's not watching this talk. Okay, so just to drive this point home, Mimi matters. So on the left, we've got, I think, well over 20 or 30 models on this platform already. These are built and used and developed by research organizations in the United States and beyond. They're also used by NGOs and the government, and then also in like recent interdisciplinary publications in journals like Nature, and that particular publication was like a collaborative effort between researchers, policymakers, and an NGO. And then also, this package now underpins the open source code for recent regulatory action within the United States, and also some in Germany. That is the word for the German Environmental Protection Agency. I have 3 German advisors, and they ruthlessly mock me when I try to say that word, so I'm not going to. But is there anyone German here? There we go. He said it. Someday I'll be brave enough, but I'm not now. So to drive home the motivation just a little bit more, so there's evidence that suggests that there's an opportunity for language designers to improve the user experience via better understanding of the user needs, these end user needs of an embedded domain-specific language. So what I mean there is there's a lot of potential benefits, right? As a designer, we don't have to write a new general-purpose language. We can just add a layer of constructs and syntax on top of a general-purpose language, use everything that's already built, use all those packages, super attractive. For users, you'd think they can do something pretty similar, right? They can depend on this whole ecosystem, package management, et cetera. But some of the literature seems to suggest that for designers, yes, super low effort, really useful. We like using this like embedded approach. But for users, it's actually a more mixed bag. And some studies have shown that for end user effort and debugging and understandability, it's actually not really living up to its potential. So the goal of this study was to understand why that gap exists and try to work on it a little bit. So again, we're trying to understand what kind of programming challenges domain experts face, and then also which ones are specifically because it's an embedded DSL. So we just kind of honed in a little bit more on that property and these relationships between the embedded domain-specific language and the host itself. And happy to talk more about the methods later, but very broadly, this was a user study with domain experts. So our experts came from NGOs, academia, and the federal government, all of them were already using the package. And the method basically was me sitting on Zoom on mute, watching these people use the package in the way they use it. So there's no quantitative results here. We're not like timing anything. I just wanted to understand what they were doing and where their pain points were, and very rarely interrupted unless I had like no idea what was going on. But I did ask them to give me sort of a stream of consciousness. And then using some kind of human-computer interaction theory, thematic analysis, we built up theories about their pain points, good and bad. And we focused on the bad, but there was a lot of good. But yeah. So second part, we have 5 key categories of findings and then related design considerations. And those 5 groups are listed here and they're in the paper. There's not even nearly enough time to go through all of these, so I'm just going to give like a little teaser of examples of the top 2, and then I'm happy to talk about more, or also just point you to the paper if you're interested in some of the specifics here. There's some on tutorials and kind of whatever your interest lies, there might be nuggets of interest. But I'm going to focus on those 2 top ones. So the first one is that errors expressed in host language concepts may slow down and confuse users, especially for those new to the host language. And this was sort of like empirical backing for existing claims in the literature, so this has been talked about quite a bit, but we found the same corroborated, so that was interesting. And what do I mean by that? Well, this quote was fun. The Mimi API errors in a similar way to the way Julia errors, such that the error messages for someone who isn't savvy in all the types, like abstract bool, can be a little bit like Morse code sometimes. So this was a user who wasn't super used to Julia, used to R, not used to types, etc. And so maybe somewhat unsurprisingly, a participant's ability to debug their code depends on them understanding error messages. And when those error messages are expressed in the host language that they might not know very well instead of their domain language, it can be quite hard for them. So on one hand, this might be par for the course, right? Like, you're going to write an eDSL in a host language. Your users are going to have to learn a bit about the host language. And that is what it is, and I think that's fair. But on the other hand, we did find that some of the design considerations and the design choices we made it more likely for them to hit certain classes of Julia errors. For example, we use macros, so they started hitting errors that are common when a macro parsing or something doesn't really work out like you expect. Newsflash, those are really, really confusing errors. So our kind of learned lesson here is that while people might need to learn a bit of Julia, we as designers can sort of at least quarter off the types of errors they're likely to get, and we can design, or we can just really add that to tutorials and really help users say, okay, if you see this type of error, this is where you can look. And then one more example, and this somewhat contradicted the literature. So the literature on embedded DSLs is to embed it so seamlessly that your user has no idea what is your embedded DSL and what is the host language. And we found that sometimes that works, but also we found that that can cause some frictions. So one example is like we had perfect seamless integration. This is kind of simple, but it just shows basically users do have curiosity sometimes about what is Mimi, what is Julia. Here was an example we haven't integrated necessarily into like the help functionality and documentation of Julia, so sometimes users don't know where to look, right? They're looking at Julia documentation, they should be looking at our package documentation. They're trying to use help in the REPL, they can't find it because it's not a Julia type, it's a Mimi custom type. So that can actually be quite confusing. And a second, maybe like nerdier example is that we tried to be fancy. So within our macros, we use syntax that looks very Julian. So we have lines that look a lot like a function call. It's not actually a function call. We write how this gets transformed. But we wanted it to look like Julia to make it simple. Unfortunately, we weren't quite clever enough. Someone was using an automatic formatter. It saw this middle line, and it put a semicolon behind the named keyword arguments. This is totally valid Julia, good practice. But we didn't put that in our macro because they get this crazy macro error that doesn't understand the expression. I don't know if you've seen expression errors. I don't even understand them, and I do code a lot. That's really confusing for a user. So there are these little things where if you try to make it seamless but you don't quite get there, you can actually get really confusing errors for your users. And I think I've kind of stated these design considerations. But yeah, so those are 2 findings that we had. And so we kind of recommend anticipating some confusion between the difference between a package or an eDSL and the host language, maybe pairing documentation to help people. So instead of rewriting Julia documentation, at least point them to the place where that might help. And then I think just like really strong attention to error messages. We catch as many as we can and then pass through with domain specific, but you cannot catch everything. They're gonna see host language errors, and just kind of thinking about that in design, I think is really important. And that's it. Thanks so much.
We have time for a quick question. You're closer.
Thanks. Yeah, that was really interesting, and I can see how that would really potentially help broaden the user base. I'm wondering if you see potential for collaboration between designers of different models like the ones we talked about today, since I think most of us are in it for people to actually make regulation or make change based on it, not just to watch the world burn. So I'd be curious on your perspective on that type of collaboration.
Yeah. So happy to talk like lots more about that after, but briefly, I think one thing that we've been lucky in is that has been basically working directly with policymakers as early as possible to understand like what their needs are and what their goals are. And then I think the other thing that's just been important is to like when we're designing this is to try, and we fail often, but we are both climate economists as well, and to really try to put our like climate economist hat on instead of our computer scientist hat, because sometimes we get too fancy because we're like having too much fun with Julia. But then when I watched users, I was like, they're not using any of the fancy stuff, right? Because like they're just using the basic stuff that like works. And so I think our priorities sometimes get mismatched depending on like who we're focusing on as our user. If we are the user, we do different things than what they do. But happy to chat a lot about that.